Hello and welcome to lecture 45. We are discussing about recent advances in turbofan engines. So, in last lecture we were discussing about the guidelines they are been given by ACARE in order to meet the requirements in terms of reduction of fuel consumption, reduction of noise and reduction of NOx emission. So, major concern we were discussing, say they are related with the weight, drag, specific fuel consumption, speed, cost, noise emission, reliability, safety. They were the major concerns when we were discussing about the gas turbine engines application to aircraft. Later on we have realized in terms of improvement of thermal efficiency and propulsive efficiency, because we were concerned about the specific fuel consumption. And we have discussed in order to meet that requirement, we have different approaches where we can improve the thermal efficiency by improving the component efficiency or say turbine entry temperature. And in order to improve the propulsive efficiency, we can address with the bypass ratio. And we are not concerned till date for say noise and the emissions regulation. Now, there are a lot of companies around in US, in Europe, in Russia, they are working with the development and research activity for the engines. Similarly, in Asia continent, if we look at, we have India, China, South Korea, Japan, they are working on the development of the engines. But most of the engines what all we are looking, they all are mainly from the Western countries. So, they are investing a lot in terms of time, money, resources and their experience. So, let us try to focus what all projects they are executing, that is what is in order to address the issues or in order to meet the requirement, that is what is given by ACARE. So, one of such project, that is what is say vital project, it is environmentally friendly aero engine. This is with the European continent, where SNECMA, Rolls, MTU, AVO, Volvo, TechSpace, ITP, Rolls-Royce, Deutschland, Airbus, they all were involved. In parallelly, there are total 52 partners, which includes university people also in this development activities, and 14 European countries like Contd from Romania, Siam Lab, Russia, they were also involved in this activity. So, this vital project mainly it was focused on, it's focusing on say low pressure part and their installation. So, just realize if we say engine for engine, this project it is mainly been targeting on the low pressure configuration. So, you can say fan, say LP compressor or booster compressor, LP turbine, that they are the targets for. So, what all they want to do is in terms of development of say new technologies. First, it is with new fan concept with the design of two type of fans, which are say counter rotating configuration and lightweight fans. New booster technology, because they are looking for highly loading with the low speed and high speed and associated aerodynamics, and in order to develop the new lightweight materials, you can say when we are reducing the number of stages for the booster, that is what will lead to improve the weight of the engine, and that is what will be reflecting in terms of the specific fuel consumption. They were looking for 30% weight saving in say engine structure, that is the reason why they have planned to move towards a polymer composite and correspondingly structure design and manufacturing technologies. 50% torque capacity without the weight impact. So, soft material, that is what they have targeted with in terms of using say titanium metal matrix composite and multi-metallic shafts. Say 20% weight reduction for say LP turbine, where they have gone with say innovative counter rotating LP turbine, ultra high lift aerofoils, ultra high stage loading, lightweight material and design solution, as well as they have targeted with the low noise design. Same way, optimal installation of the bypass ratio, which is related with say nozzle, nacelle, thrust reversal, positioning of the engine, optimization in terms of weight, noise, fuel burn. So, you can say this project has many objectives, and this project in which many industries and many universities they were involved with. So, let us look at what all they have targeted with. So, for this project they have targeted these three kind of configurations. One, it is say direct ducted fan architecture. Second, that is what is related with the gear turbofan architecture, and third, that is what is related with say counter rotating turbofan architecture. So, here if we look at this is related with the duct, or so we can say ducted fan, that is what is been driven by say LP turbine. In the second configuration, if we look at, that is what is with the gear turbofan engine, where in order to reduce the rotational speed of the fan, they have used the gearbox. That is what will be driven by LP turbine, and we have seen what all are the advantages of using this kind of configuration and what all are the challenges in terms of designing the LP turbines. And third configuration what they have targeted, it is counter rotating configuration, that is 3 spool configuration. Here if we look at, this is representing my HP spool, and here in this case this configuration we are having counter rotating configuration both for the fan as well as for the turbine. Okay. So, let us look at what all they have targeted with. So, here in this case if we look at, this is representing what all they have targeted with. So, this is the conventional standard turbofan engine, and they want to have two kind of research for say counter rotating configuration, design 1 and design 2. For design 1 they want to have same fuel burn as the standard turbofan engine, but they want to reduce the noise. Okay. And for this project Shyam Lab Russia, DLR, they are involved, and this project as we say it is a vital project. Parallelly, they have executed other project which having say design configuration where they want to reduce the fuel burn as well as they want to reduce the noise. And in order to address this, the project, that is what is named as a dream project. So, you can see here in this case, by having this kind of configuration, they want to move towards a reduction of noise, and for that configuration the dimensions they are same as the conventional engine. Now, the thing is, if we are looking for this kind of engine architecture where we are looking for low speed of fans, we are looking for the load sharing between these two rotors which will be rotating in opposite direction. Then we are looking for say fan diameter, that is what will be lower compared to our conventional engine. Target is also in order to reduce the noise, and that is what will be giving the benefit in terms of thrust to weight ratio to be as high as possible. Okay. So, let us look at what all they have done with. So, these are the 4 research fans. First, that is what has been developed by say SNECMA and Shyam. So, that is what is named as CRTF1. Second, if you look at, this is what is with the single rotor fan, that is what was developed by the SNECMA France. This configuration, that is what is been developed by DLR in Germany, and this is the one which is been individually developed by Shyam Lab Russia. So, the whole target for doing this research is in terms of improvement of the performance. Secondly, that is what is to improve the specific fuel consumption, and main target, that is what is related with the noise. And finally, the outcome of that project, they realize they are able to reduce the noise by using SNECMA Shyam project, and this kind of configuration, that is what has helped them in order to minimize the noise level. Okay. At the same time, if we compare other configuration, they are comparatively noisier one. Okay. Now, the thing is, this research, that is what has given the idea for the future engine development. So, let us look at, later on they realized this counter rotating turbofan engine, they have executed one more project, that is called Cobra project, where Commodity, Onera, Safran and Shyam, they together they have explored the possibility. What they have done, they have implemented this counter rotating configuration for the ultra high bypass ratio ducted fan, and the application they have targeted is short and medium range aircraft. Okay. At the same time, in order to decouple the rotating speeds of both the fans, they have used the gearbox. So, you can say it is a combination of ultra high bypass ratio fan with the gearbox configuration in counter rotation. Okay. Now, this is what is one of the successful project by Russia. The design, it was proposed by the professor in 60s, and later on they have come up with this development of engine. Here you can see the construction of this engine, where the fans are counter rotating, and here downside if we look at, it is having say bypass ratio to be higher in the range of 12 to 15, and these are the number of stages you can see in terms of LP, HP. Okay. Now, let us look at what all are the benefit in terms of using this ducted counter rotating fan. So, basically the target it is to increase the thrust. Here in this case, since we are sucking the air from the front rotor, that is what suppose it is rotating in clockwise direction, then the other rotor it will be rotating in counterclockwise direction, and that is what will be increasing the energy extraction of the incoming air. If we are comparing with a single rotor, it is higher compared to our single rotor configuration for the similar size as well as power configuration. And when we are having this incoming air capacity or sucking capacity to be higher, that is what will lead to improve the thrust. Secondly, it says it will be improving the efficiency, because you can understand here in this case, this configuration it is giving the better utilization of the airflow, and that is what will be improving the propulsive efficiency as we have discussed, and that is what will lead to improve the specific fuel consumption as well as overall efficiency of the engine. Since these two rotors they are rotating in opposite direction, that is what is giving benefit in terms of wider operating range also compared to our conventional engine, and that is what has attracted the attention to move towards the ducted counter rotating fan. And here if we look at, it also gives the benefit in terms of say reduction of the noise, because these rotors they are rotating at lower speed compared to the conventional or traditional fan, and it says by their study, by proper aerodynamic designing of these blades, it is possible to reduce the noise emission. It saves the weight of the engine, because we can say we are not having say additional component in terms of say stators to be placed for say LP turbine. So, it will be reducing the number of static components, that is helping us in terms of improving say the weight of the engine, or we can say reduction in the weight of the engine. And here in this case, since we are having two rotors which are rotating at high efficiency and the performance for the same thrust configuration, we can have the diameter of these fans to be lower. Okay, that is the outcome of this research, and it says we will be having this engine to be shorter, because we are having this counter rotating arrangement, and that is what is giving the advantage in terms of application of such configuration for military purpose also. Okay. So, it says like we will be having say different kind of configuration. So, this is one of the configuration which was been explored by Rolls-Royce, where as you recall in week 9 last lecture, we were discussing about using say aft fan configuration. So, in line to this we are having say aft fan configuration, but this will be having counter rotating fans which will be rotating in opposite direction. At the same time, if you look at carefully, these turbines they are also counter rotating. Okay. So, Rolls-Royce they are targeting, they are working at this moment in terms of development of such kind of ultra high bypass ratio turbofan engine or say advanced turboprop engines. In this case, if you look at, this is representing say wide body aircraft, where we will be having passenger carrying capacity to be huge, where we will not be having, in order to have the lift to drag ratio to be maintained, we cannot accommodate such engines below the wing. And for this kind of configuration, we need to accommodate our engines on the rear side, you can say like this. And if we will be using this kind of engines with the contra rotating configuration, it is putting the additional benefit, a benefit in terms of 30% reduction of the fuel, and it says we will be having this as the future coming engine. So, you can understand here the ducted contra rotating fan is getting attraction towards the use for the future configurations. Okay. Now, parallelly, if we look at people, they are also focusing on say fuel burn as well as CO2 emission. So, here in this case, if we look at say LIP 56 engine, that is what is meeting with all the requirements, that is what is being targeted by ACARE, and that is the reason why that is what has been taken as a reference here. And as we discuss, people they are targeting towards the improvement of specific fuel consumption, and the target here it is to reduce say fuel economy by 20%. And if we look at here, it says the success rate of these projects are moving towards, still it is under the configuration. Parallelly, there was a thought process in 80s, it's related with the open rotor configuration. So, GE they have done their work in 80s in order to develop the contra rotating open rotor configuration. So, that was a time when there was an issue with the fuel price that has raised a lot, and in order to meet that requirement, they started doing research and development activity, and they have come up with this engine. I will show you the details, and it says it is able to meet with the requirement of fuel economy in terms of 20% reduction. You can understand here we are talking about all ongoing project. At the same time, here this is already meeting with what all requirement we are looking for. Similarly, this is what is with the Russian engine, and parallelly there is a dream project for open rotor, it is going on. So, it says we are able to reduce the fuel burn even below the requirement it is targeted by say ACARE. So, fuel burn reduction and the CO2 emission, that is what is related with the thermal and propulsive efficiency, and we can say propulsive efficiency we can improve by increasing the bypass ratio, and when we say when we are using this open kind of rotor, we are moving towards the bypass ratio in the range of 40:1. Now, parallelly we need to also think in terms of noise. So, here if we look at this is our standard baseline, where we are having say noise emission that is lower compared to what all we are discussing about the open rotor configuration, and we are targeting with the reduction of 10 decibel per point. Here in this case, if we look at this open rotor configuration has issue in terms of noise, but still people they are moving towards the achievement of what targets we are having. There is a parallel project, that is what is going on for say ducted fan configuration, it is silencer and vital project. But if we look at carefully, it says like open rotor configuration also has the advantage both in terms of fuel economy, and if we move towards a careful design configuration, it is possible to meet the requirement in terms of noise. And it says aircraft dedicated installation, that is what is becoming very much of need in order to avoid this noise issue. So, you can say parallelly the world has started thinking in terms of development of open rotor kind of configuration. So, you can say we have high bypass ratio engine, we have say gear turbofan engine, we have ultra high bypass ratio engine, we have contra rotating ducted kind of configuration, and parallelly now people they started thinking in terms of open rotor configuration. So, let us look at so what all are the developments. Say during 70s and 80s there is contra rotating open rotor configuration that has come. Very first trial it says that was done by GE, that engine is G36, it is having pusher kind of configuration, where they have direct drive. And this project, it was in collaboration with GE, NASA and SNECMA, and they have done their testing for McDouglas 80 as well as for Boeing 727. Later on, that was developed by say Pratt & Whitney Allison, it is 578. It is having say pusher kind of configuration, but with the geared contra-rotating open rotor. That was developed by Pratt & Whitney Allison and NASA, and that has flown for MD-80. In parallel, there was a development activity which was going on in Russia, that is what is D-236 and D-27, which has a puller geared contra-rotating open rotor configuration. Still it is in use for Antonov AN-70. So let us look at what all, how they are looking like. So here in this case, this is representing say G36 engine, and that is what is having say non-geared kind of configuration. So here if we look at, we are having this as our front rotor, and second, that is what is say second rotor, or say these two rotors if we configure, they both are rotating in counterclockwise direction, or we can say it is a contra-rotating kind of configuration. You may say, sir, this seems to be similar to our turboprop engine, it seems to be like a prop engine, but be careful, this is not the turboprop engine. Turboprop engine, it has its own limitations. Those limitations, those barriers, they are being crossed by this kind of open rotor configuration. We will see what all are the barriers, that is what is being crossed with. Here if we look at, this is representing Pratt & Whitney Allison engine, where they have used the gearbox technology, and that is what is also rotating in counterclockwise direction. So they have two rotors, they are being placed on the aft side and they are rotating in counterclockwise direction. This is representing D-236, it is similar way, but in this configuration they have this contra-rotating configuration, it is on the front side. Okay. And this configurations, they are being designed in order to go with say Boeing 7J7, and that is what was a target to replace 727. But later on they have stopped that project, and this development activity, that is what was stopped long back. Later on say GE still has continued their research and development activity in collaboration with the SNECMA, and recently in 2017 this is been launched by SNECMA. SNECMA now it is known as a Saffron. They are having contra-rotating configuration. So what all configuration which are being used for G36, same configuration they are being used by SNECMA in terms of all the parameters. Only difference here, they have used the geared configuration, rather not going with say non-geared configuration. Okay. So here in this case, it has its own challenges, as we have discussed. This is having two rotors which are rotating in opposite direction. So we can say the wake which will be coming out from the front rotor, that itself is generating the noise, and that is what will be sucked by the rear rotor, which is rotating in opposite direction, and because of cutting of this wake, it is generating lot of noise. And SNECMA, they are claiming they are able to manage this cutting of this wake, and they are able to manage the noise. Okay. So these are the configuration, different configuration they have explored with. Here it says a contra-rotating kind of configuration with the direct drive, then they have moved with say rear gear drive, front drive, as well as they have tried with the single propeller also. And if you look at, this is the cut section of this engine. On the rear side, they are having say gearbox, that is what will be lead to rotate the rotor as per the requirement. And here if we look at what all are our requirement, they are in terms of flying at Mach 0.78 or maybe 0.8. Now let me discuss here what turboprop engines we are discussing. They are not been made for flying at this Mach number. At the most they can fly at say Mach 0.4 or 0.45, because it is having its own limitations. and those limitations, those barriers, they are being crossed by this kind of open rotor configuration. Here it says when we are going with say front gear configuration and the single gear configuration, it gives the benefit both in terms of weight as well as say the noise. Okay. So, let us look at what all overall people they are started thinking of in order to meet the requirement by Akare. So, it says we were moving towards a use of high bypass ratio engine. Later on, in order to reduce the noise emission, they have gone with say counter rotating kind of very high bypass ratio configuration, where the fuel burn also has improved, at the same time the noise emission also has reduced. Now, the new target, that is what has come with the bypass ratio of 45, it is giving great benefit in terms of fuel burn, but at the same time in terms of noise, that is what is the issue, and people they are addressing this issue with different kind of engine configurations. So, here these are the configuration which are being explored by Rolls-Royce in line to what all we have discussed earlier. Here in this case they have gone with say pusher kind of configuration with the gearbox, and this is representing say puller kind of configuration, in which these two propellers or two prop fans they are placed on the rear side, and they are also exploring what all are the challenges in terms of placement of these engines. So, here if you look at this pusher type of configuration, that is what can be placed below the wing. At the same time, when we are discussing about the puller kind of configuration, that need to be installed on say if we look at here, it is on the upside of the engine, and basically that is what is on the fuselage, and that is what is with the target of how my aerodynamics, flow aerodynamics will be getting addressed with. So, placement of such engine, that is also very challenging. Now, if we look at it says this kind of configuration, they are having so many challenges. So, basically they are being segregated in two ways, at the aircraft level and at the engine level. So, let us look at what are the problems or what are the challenges at the aircraft level. It says noise emission. So, we have cabin and community noise, that is what is a big issue. Second, that is what is in terms of structure. So, fuselage and the structure fatigue, that is what is in the proximity of engine is very challenging. The placement or installation of the engine and installation weight also is a challenging part. In terms of aircraft aerodynamics, when we are installing these engines on the rear side, where we need to take care of what all we have discussed earlier in terms of CG, in terms of control surfaces for the aircraft, and at the same time aesthetic look and the safety. So, it says like public perspection, that is what is very important. Just imagine you are sitting in the aircraft, and from the window if you look at, there are two rotors which are rotating in counterclockwise direction and they are open. So, it gives the scary kind of environment, and it may be possible that people will avoid sitting in such aircrafts. Suppose if it is installed below the wing, there also it has challenge. At the same time, when it is placed on the rear side, that also is very challenging, and that is the reason why now they need to address this issue in terms of safety aspects also. Then at the engine level, if we look at, we are having small core, and that is what is required, a specialized cooling mechanism. At the same time, like thrust reversal kind of configuration, it is very challenging and difficult. What we are discussing about say mechanical design of pitch control, we will see what all mean by the pitch. Say here in this case, if you look at these rotors, what we are discussing for the prop fans, they are having say they can change their orientation as per the operation, as per the requirement. That is what is called variable pitch kind of configuration. And when we say it is rotating, under rotating condition, you need to actuate that mechanism, and that need to work, it is very challenging. Same time we are having say gearbox reliability. We have discussed this aspect when we were discussing about gear turbofan engine, the oil cooling requirement. say maintainability and acceptable maintenance cost, and at the same time we are having contra rotating turbines where we are looking for sealing and the blade containment. They all are very challenging aspects. So, currently all these engine manufacturing companies, those who are working with the design and development of such open rotor configuration, they are trying to address all these issues. So, in very near future, people they are claiming by 2035 this kind of open, say unducted kind of configuration, that is what will be in use for say medium range aircrafts. There is one more project, that is what is going on in parallel. It is called RISE project. It has major attraction these days. If you look at in media, everywhere we are having this project, it is coming in the limelight. This project is in collaboration between GE Aerospace and Safran, and the whole target it is to reduce the fuel consumption and CO2 emission. And this RISE project, it is having variable pitch configuration with the single stage, and it is also having say single stage or stationary outlet guide vane. Now, the thing is, this has initiated from the project, it is called QCSEE. It is quite clean short haul experimental engine, and that is what has helped in order to develop this kind of configuration. So, what concept of composite fan blade they have developed for GE36, that is what is being used for GE90 as well as for the LEAP engine. Same concept it is been used for the development of the blade for this RISE engine. And Safran they have taken the same configuration here in this case, and they say they are able to reduce the noise, and that is what is equivalent to level of LEAP engine. And that is what is with the project, it is called Euro Clean Sky Research Project. Now, here in this case, as we have discussed, say contra rotating unducted fan, that is what was developed by GE in 80s. They have not stopped at research and development activity. They were trying to identify the source of noise, and gradually they have come up with the solution for the reduction of this noise. Okay. And that is what is with the Avio Aero. In terms of the project, it is called Clean Sky Program on iron with Leonardo. Now, the configuration what we are discussing for say RISE project, it is single unducted fan. What is the whole idea? It says this has a simplicity of turboprop. We are having single rotor, and that is what is been with the incorporation of say we will be having fixed D-swirl stage. Okay. Same way, it is a single stage variable pitch fan blade, that is what is rotated in the front, and on the rear side we are having say outlet guide vane. It is not having any complex contra rotating gearbox kind of configuration. So, it says that is what is making this engine to be simpler compared to what all we are discussing in terms of turboprop engines. So, let us see how it is looking like. So, here we are having the rotor blades, they are made up of carbon fiber composite blades, and on the rear side if we look at, this is representing the outlet guide vane. So, during the operation it has a provision to change the pitch as we are seeing in turboprop engines. Similar concept we are having here. At the same, in order to manage the flow, this outlet guide vane also can be adjusted as per the requirement. Now, the benefit here is mainly in terms of fuel economy, and secondly what all we have discussed in terms of issue with the noise. So, here if we look at, it says when we are moving or when we are discussing about already existing the best engine, it is LEAP, and when we are moving towards say open rotor kind of configuration, it says it is giving the improvement in propulsive efficiency, but at the same time it has lot of issues in terms of engine installation, engine placement. We have discussed all these aspects. Now, this engine has to thorough with the expectation of flying Mach number around 0.8, that is what is our turbofan engine similar kind. It need to show the improvement in terms of efficiency. noise level also need to meet with. Maybe it need to change with the diameter. At this moment we will see what dimensions these people they are talking about. At the same time, how it will be installed on the aircraft. Here if you look at this is the earlier engine, that is what is with the contra-rotating configuration. And if we look at carefully, in order to address the issue of say safety, when they have installed this engine, they have done the reinforcement for this particular region, because in case of failure of any blade that will be coming out with very high Mach number, it may be possible that it will penetrate within the aircraft, and that is what is very challenging, and it is a scary situation. Okay. Then we need to go with say blade out, that is what is a big issue as we have discussed. At the same time, the noise and vibration level, that also will be the issue, and very important aspect, it is clean sheet aircraft, means in order to use this you need to have the technological readiness and the acceptance of the aircraft or airline company also. At the same time, certification agency also has to develop their guidelines, and that is where the whole challenge will come with. Currently this engine is having bypass ratio of around 20:1, and they want to test this engine with say 100% hydrogen fuel in very near future. Okay. Now here if we look at this is representing what all we are discussing at this moment. It says for past 2 decades globally people they have gone with lot of research and development activity for the commercial aircraft, and where the target is in terms of fuel economy, in terms of emission, in terms of noise. If we look at this is representing the turbofan engine. Later on people they move it say gear turbofan engine, then they are discussing about say advanced ducted propeller, then they are having say other kind of configuration where we are having say propellers they are being installed with super fan kind of configuration. This is representing the ducted contra-rotating kind of configuration. Later on we were discussing about the contra-rotating prop fans and unducted fans. So you can imagine this is a representation of what all we are discussing in terms of meeting the requirement. That is what is been forced by ACARE as Vision 2020. So here we are stopping with the discussion in terms of say development activities for the commercial aircraft, what all are the ongoing projects. In next lecture also we will be discussing about the ongoing projects, and there later we will be targeting the military engines also, because those engines are also equally important. What all we are discussing at this moment in terms of fuel economy, in terms of noise emission, in terms of say the emission, that is what is in terms of CO2 or NOx, that also will be equally applicable for the future engines. We also will be discussing something in terms of what people they started talking in terms of hybrid engines. So stay with us, we will be continuing discussion about all these engines. I am sure you are enjoying this class, and in order to go for more detail I have cited the courtesy. You can collect those papers which are available on internet. Thank you very much.